All right, we're going to talk about the Pythagorean identity. Okay, so let's begin with the unit circle. And what I'm going to talk about sort of assumes we know something about circles. The equation of a circle with radius 1 centered at 0, 0 is x squared plus y squared equals 1. So that's the equation of the circle. Just put xy here. And really that comes about by using the distance formula, which follows from the Pythagorean theorem. If we draw the picture like this, then along the horizontal is x, along the vertical is y of this right triangle. So what we can do is, and we do this quite a bit, is insert a right triangle here. And this x and y is a directed distance, so it could be positive or negative if my point is somewhere else besides what they call the first quadrant. So, but the Pythagorean theorem gives x squared plus y squared equals 1, and we can also use the distance formula. We can use the distance formula to find this, but this is the equation of a circle with radius 1 centered at the origin. We have x equals cosine theta, y equals sine theta, which gives us from x squared plus y squared equals 1, cosine theta squared plus sine theta squared equals 1. Now, this is the Pythagorean identity. It is like universal that we don't write it this way pretty often. It's sort of rare we write it this way. What we do is we put the 2 right above the s like that. It is not the same if I put the squared symbol above the theta, because that means that I'm squaring theta. Cosine theta parentheses squared is written this way. And so this is the Pythagorean identity. And it's really the one that we can I use all the time. Okay. So let's do this example. I'm going to look at this picture here. And let's look at this angle theta. And all of a sudden I have this idea of just doing this in my head right now on the fly instead of really thinking this through. But okay, let's have this point negative 3/5, and this is 4/5. Okay, so A, referring to the picture, to the diagram, to the graph here. Is it really a graph? Maybe it's a diagram. Okay. Find cosine theta, sine theta. Okay, so cosine theta is equal to, so this is our solution. So those are the directions. Here's our solution. Cosine is the x-coordinate, so this is negative 3/5. And sine theta is the y-coordinate, and that is 4/5. All right, and so then, there we go. So then part B, verify that these values satisfy the Pythagorean identity. All right, so I have cosine squared theta plus sine squared theta equals 1, and I just want to verify that this is correct. And, you know, the problem with this is there's fractions. So this is 9 over 25 plus 16 over 25 equals 1. I keep putting question marks, but this implies 25 over 25 equals 1, which is certainly true. So that did work. So, you know, one thing is it's not going to work that I just put any 2 points and say, okay, they lie on the circle. They have to satisfy the Pythagorean identity that cos x squared plus y squared equals 1, or cosine squared theta plus sine squared theta equals 1. So there are a lot of constraints on what two coordinates will lie on the unit circle. All right.